Good evening, everyone. Welcome to the second week lecture of water and wastewater treatment. The instructor of this course is Professor Bhanu Prakash, and I am one of the TA Manyatnam Prakash from IIT Kanpur. So, as already discussed, that this discussion session will occur every Tuesday from 7 p.m. to 9 p.m. and this will be a online meet via this Google link that is Google Meet link that is shared to you via mail from NPTEL team. So in second week of the lecture, following things were discussed. First of all, the mass. Uh, Hello, welcome Varun. So you have joined when you have joined this lecture session. So just can you confirm? Are you able to see my screen? Mr. Barun, can you please confirm? Okay, thank you for the confirmation. So, welcome to the second week of the discussion. In this week, mainly five topics were discussed in details way. That is mass balance, about different kind of about batch reactors, CSTR, plug flow reactors. Then there was a discussion about mass balance, which include again second topic in mass balance, that is comparison of CSTR and plug flow reactor. And third subtopic in mass balance was non-ideal system and water quality parameters. And in the last two topic which were discussed in this second week was DO and its ways to measure, and the last thing is the water quality and nutrition in the water. So in this, I have already said that in this here we are only to discuss some of the important questions that might be asked to you in quiz or final assessment that you will be giving. And these questions are previous year questions. So I will be discussing it one by one. If you have any question, you can raise your hand. There is one option of raising your hand, and you can ask, or you can just type in the chat box that you are facing some kind of problem. So the question is in this manner only. First, there are some question related to this mass balance, then this DO, and finally some question is related to water quality. So coming to the first question, which is the all questions are very simple question. If you have gone through the video lecture on NPTEL, then you will be able to answer all the questions. So let's discuss this question one. There are around 10 questions, and I will discuss it one by one. Coming the first question, the first question is the rate of reaction depends upon. There are three options: product, reactant, and both product and reactants. So to answer this question, you must have idea of chemical kinetics. So first of all, I will discuss about something about the kinetics. And if you have any problem in audio, please let me know. I hope everyone is able to listen me clearly. If you are facing any kind of problem, just let me know. So the first question was the rate of reaction depends upon out of these three on which thing. So first we have to know about the chemical kinetics. This question is from chemical kinetics. So see, in second week you have been discussed this thing, batch reactor, CSTR, plug flow. But to know the what kind of how this system works, how this reactor works, you must have an idea of chemical kinetics, because all the equation which is discussed here is all related to chemical kinetics. So the if we come to the chemical kinetics, so it is a statement is that the rate of reaction is typically expressed in the change in concentration of either reactant or product per unit time. So now suppose there is one general reaction. So what will happen, that this A will react with B to form C and D, and a small a, small b, small c, small d are stoichiometry of this reaction. So what will happen, that this reaction will with time this will react with this, and C and D will form. So what will happen, the concentration of A and concentration of B will decrease, but at the same time concentration of C and concentration of D will uh, uh, increase. And the how in how much this concentration will increase decrease, this all depend upon the stoichiometry. So the rate and the rate at which this decrease in concentration with time that will happen is expressed in this term, that is dA by dt. So if you read the statement say, just 1 minute. Hmm. If we look at the statement, so as you already said that A and B are the reactants, C and D are products. The coefficients A, B, C, D are the stoichiometric coefficient of each species, and the rate of reaction is expressed already say the concentration of either reactant per unit time. So what will happen, that A will react according to dA by dt. Similarly B will react, and there is negative sign because with time concentration of A will decrease. Similarly for B the concentration will decrease, that's why it is minus. And the on the other hand concentration of C on the other hand the concentration of C and D will decrease, that's why it is there is a positive sign, or we generally do not write positive, so we write it as it is, that is dc by dt and dd by dt. uh, dd by dt. So here these are the represent the change in concentration of respective species over the time. So what happened, that already said that the negative sign indicates the consumption of reactants, while the positive represents the formation of the products. And the stoichiometry are the used to relate the rate of concentration of a species in the reaction. So how this means how A is decreasing, how B is decreasing, all depends upon the stoichiometry and this rate. So the question why the rate of reaction depends upon. So you can see this is a general reaction. So rate of this reaction can be controlled by both A also, B also, C also, D also. So our correct option will be the rate of reaction depends upon the both product and reaction. So this is a simple question, but sometimes what you will see that generally this is not asked. What happened, that we do not ask the rate of a reaction, always write, we always ask that if this is a reaction, what will be the rate of reaction with as respect to capital A, small b. This is how related, but if someone is saying that find the rate of reaction, you can use out of these four species, that is A, B, C, D, you can express in any term. If you depending upon the data which you have been given in the question, you can you can express the rate of reaction in any one of the species out of the given four. So the correct option for this will be C, that is it depend upon the both. Yeah, I will be explaining order of the reaction in the last, because I have to first I'm discussing the some basic question, but I have some slides which will also which I will be discussing in the last. So okay, if you have asked it, then I will discuss it now only. What is the order of reaction? So just let me go. This was let's just let me go in the last slide. So this thing already I have said that a reaction, a stoichiometry, and all this thing will depend upon this thing. So the reaction kinetics generally this is three. They are three. Now suppose what will happen, that when this will react with this, there will be some kind of order. Either what will happen, that this change in concentration will be directly proportional to this concentration, or it won't be depending upon this concentration, or it will be the a square of this concentration, or it can be in any in nth kind, that is called nth order. So then for our study we generally take three kind of order, that is zero order reaction, first order reaction and second order reaction. And there is, miss, if you go through this, I will refer one book from where I have collected all this material. I have collected the all these equations and all. So you can go to that book, and you will see that they have generalized all these things. They have not discussed zero order, first order, second order separately. They have just generalized it at nth order reaction. Suppose you have been given some set of reaction, and you are asked to find that what is the order of this reaction. So you can, there are different method discussed in that book. I will just refer at after the end of this slide. So as discussed, that for zero order reaction, what will happen, that this change in concentration will be depending on the power, the how we do say that, how we say that the change in concentration is proportional to the zeroth power of this concentration. And we know that this zeroth power means it will be equal to 1. So means the change in concentration is just proportional to the rate constant by which this the concentration of this thing will change. So, and for each and every order there is some kind of equation, like you can derive the equation by which that product, yeah, that reactant will form, yeah, their concentration will decrease. So I will be deriving the equation for each and every one. So as already said, as we know that for zero order, what will happen, that it won't be depending upon the concentration C. So this dc by dt will be equal to minus k, and I am assuming that the concentration of C is decreasing with time. You can modify the equation as per your reaction also. Suppose for any you are deriving the equation where the concentration is increasing. So this just minus k is just showing that this concentration of C is decreasing with time. So what will happen, that at t is equal to 0, the concentration of C will be initial concentration that we represent via C naught. So what will happen, that I will do integration on the both side. So so from the mm, given data, we know that at what will happen, that this dt will be go this side, and C will be here alone here. So we know that for time variable at t is equal to 0, the concentration was C naught, and for t is equal to t, the concentration will be something C. I'm just referring at after some time C, the concentration will be C. So if you do the integration, you will get this, that C is equal to C minus C naught. This will result into C, and this will equal to C minus C naught. And here this the integration will be T, and it will be T minus 0, that is equal to 2, and there will be some um, constant C. This C and this C is different. This is constant. Okay, do not get confused. So now if we put the initial condition, that is at t is equal to 0, t at t barabar 0, the C is equal to C naught, you will get this the value of constant will be 0, and your final equation will be C is equal to C naught plus T. So how this equation is, this is a first order zero order reaction, whose equation is this, and how this equation you will be using for your exam or anywhere. I will discuss it via one example after this slide. So similarly for second order, what will happen, that dc by dt will be directly proportional to the concentration of the C. So again here same condition, that and I am putting minus sign because the concentration is changing. So at t barabar 0, the concentration will be C naught. If we do the integration, then this dc by this C will come this at the dominant denominator, and dt will go there. If we do the integration problem, integration, simple integration, then we know that the integration of dc by C will be ln C. And if we put the upper limit and the lower limit, the final equation will be ln C minus ln C naught. And similarly for the time, the integration will be for as k is constant, so this dt will be simply t, the final equation will be this. So if you just apply the logarithmic, and here also If you put the value of c, if you put the initial condition that at t is equal to 0, c is equal to c naught, then you will get the value of c is equal to 0, and you can directly get this equation. So I have written two in two form. You will be getting the first order the equation for first order in two condition, that is c is equal to c naught e minus kt, or there will be a simple equation that is ln c is equal to ln c naught minus kt. So in general, what will happen that you, whenever they are talking about first, what is the first order reaction, you can just say that it is an exponential equation which is represented as c is equal to c naught e minus kt, and if you take ln on the both side, you will be getting this equation. For the first order, for the zero order reaction, C will be directly proportional to this C concentration is directly proportional to the time. But here in this case, log of concentration is directly proportional to the time. Similarly, for the second order reaction, what will happen that the concentration will be proportional twice a square of the concentration. So at t is equal to 0, again the same condition, again I will do the integration. I will come after you will do the integration, you will get this equation. Here what you are getting, that inverse of this c is directly proportional to the time. So for all these three equation, you have got the equation. So now how I will use this equation, I will discuss it via one example. Before coming to the example, so this was first order reaction, second order reaction. Now if someone want to generalize this thing, suppose instead of I am putting here, so first time I am putting 0, then second time 1, then 2. Suppose if you want to generalize this thing, that dc by dt is equal to proportional to some nth order. So for that I will just refer one book, just please go through that book. That book is very whatever you in my screen visual, please anyone confirm. Yes. What I am using this book, that is Surface Water Quality Modeling by Steven C. Chapra. So whatever miss, if you miss this equation, this book contains everything, like the complete discussion about mass balance, which you have gone through in the second lecture. So this second lecture is, that is reaction kinetics. Here you can see this book mainly focus on CSTR, PFR, and batch reactor. So lecture 2 is of reaction kinetics, that is on page number 24. So see here, what you will see, that first they have discussed about this what is it integration now. So they have discussed in the general modes. First they have discussed as usual, because most common this zero order, first order, second order is very common. So what they have done, they have generalized the thing, and by generalizing it, yeah, they have tried to solve this by different method. So suppose your equation will be your simple equation will be this thing, that is dc by dt is proportional to is equal to minus k c ki power n, that is nth order reaction. So there are several method to solve it, that is integral method, then differentiation method. So if you are method of initial rates, method of excess, so there are other methods. So if you are really interested in to know more about chemical kinetics, please go through this book. This book is available on the internet. You can just type uh, this surface water quality modeling by Steven Chapra PDF. You will get this PDF and you can read it. So miss to get more control on this different kind of reactor, that is CSTR, PFR, you should read this book, because most of the material that has been covered in your lecture also has been taken from this book only. And whatever derivation and examples I will be doing, I have also used referred this book only. So whatever I am saying is present here. So it's my suggestion that please go through this book. Okay. So now you have all three equation. So the question, there will be some general simple type of question can be asked from you, that what is the equation for zero order reaction, first order reaction, second order reaction. The main question which come is like there has been one experiment performed and the data has been collected with time, that is zero point 0.5 minute. The concentration is this. So they are asking you to find the order of kinetics. Okay. So you will be asked to find the order of kinetics. So how you will solve? So for solving this, we know that this is the equation of for zero order reaction. This is the equation of first order reaction, and this is the equation for second order reaction. So what will happen, that I will take the help of Excel sheet. Okay now. So generally in exam you can in examination also you won't be getting laptop, but so what will happen, that this question will be how this manually numerically how this question is solved. You can take the help of that book. But suppose if you are explaining something, yeah, if you are doing some kind of research and if you have done some experiment and you want to check that what kind of order is that, then uh, you can follow this method. So with time you have concentration. So what will happen, that I know that if the reaction is zeroth order, the C will be directly proportional to C naught. The C will be directly proportional to time. And for first order, the ln of this concentration, ln of the concentration, log of this concentration will be directly proportional to time. And for second order reaction, it will be 1 by C, which will be directly proportional to the time. So I will plot the graph of each and every one. So first I plotted C versus time. So this graph is C versus time. That is, I have taken C, then time. So and I have calculated R square. How R square is calculated? R square is you can calculate directly from this use of Excel. So here there is one option to display R square. Okay, now this to display R square and to display equation on the chart. Okay. So what I have done, then I have I have plotted this and the R square come to be 0.91. And similarly I have plotted LNC versus time. So here the R square come out to be 0.99. And similarly for the third, for say to check that it is second order, the R square come out to be 0.832. So how can we decide that which one is correct answer? So from the graph you can see that uh, the R square of this, when I have plotted the R square of R square for first order reaction, then it comes out to be 0.991. So what this R square represent, that how much you have deviated from your original data. So so if your R square is equal to 1, means you have not deviated from your original data, means original means measured data. Yeah, you can say this is a kind of comparison between your plotted graph and a straight line. So what will happen, that if I am plotting a straight line for if I am plotting a straight line, so what should happen, that this for this all the value of lnc should have been one straight line. But there is some difference, there is some deviation from the original data, or miss this straight line. So there will this r square will vary. So so it is said, if you are aware of this r square, then it is okay. If you are not aware, then no problem. Just remember that the if the r square value is equal to 1, yeah, closer to 1, then then it is said that that data fits suitable for that equation. So out of these three equation, these three order r square for first order kinetics comes out to be 0.9961, which is closest to 1. So hence the experiment which was done follow the first order kinetics. So this was graphical method that you will plot the graph and you will calculate the r square. So now suppose you don't have this excel, yeah, you cannot calculate r square for each end. So then what I have suggested that you can take the help of this book. So they have given some method. So you don't know the order of the equation, and they have given some instruction that you do this step, you will be able to know the order of kinetics. So I hope this is clear to you. So this was related to the first question, that how to find order of order of any reaction. Is it okay? If you have any doubt, you can ask now. Else, I will be going to the second question. Okay. So coming to the second question, that is, in a CSTR, the concentration in reactor is same as the concentration in the effluent from the reactor. So to answer this question, first you should know about what is CSTR. So actually this CSTR thing is very detailed thing. I cannot explain in one class, because a professor, yeah, teachers take around 4 5 lectures to explain each and every concept of CSTR. But I will be just giving you summary how this CSTR thing work. Again, so the CSTR stand for continuous stirred tank reactor. So from the name, it's already suggests that there will be a tank which will be continued stirred. So how this is graphically represented? This represented in this way. So consider this any kind of control volume, yeah, any kind of lake. So what will happen that some kind of loading can be wastewater loading, yeah, any kind of pollutant in the water, and it will go in the lake, yeah, any volume reactor, and it will be continually stirred means continually mixed. Okay, and there will be some kind of settling, and sorry, some kind of settling, and there will be some kind of reaction also. So what will happen that initially there was concentration of x, so it will come here, there will be some kind of reaction. So that reaction can either increase the concentration of this pollutant, or can decrease the pollution of the concentration of the pollutant, or similarly can be some kind of settling. So after some time, what will happen that if sufficient time is given, that pollutant will come in the equilibrium, and it will go outside your system. So what will happen that there will be some kind of after equilibrium, there will be obviously some kind of accumulation. So accumulation will be given in is given by this equation. Accumulation will be given by mass in, means how much loading is coming, how much is going out. Obviously there is some kind of reaction, and obviously there is some kind of settling. Okay now, so this is this accumulation. So this accumulation can be positive also, can be negative also. How can be this positive negative? Suppose there is too much settling, or too much reaction. It all actually this reaction controls everything. Suppose there is the reaction is such in such a way that the concentration of this pollutant is decreasing. So obviously this will be a huge negative term, and obviously we have to assume other thing also, that mass is very less. So this will be overall, there will be a negative thing. Similarly, this can be positive thing. So you can see that accumulation so the outflow which will be coming up will be coming after all the kind of reaction has happened from it. Okay now, so whenever we do any experiment from in CSTR या UB analyze a lake, so what happened that we assume that whatever will come here, it will attain some kind of equilibrium, and then it will go out. So what will happen that whatever the concentration will be here will be going out from the here. So the question is the concentration in the reactor, consider this as a reactor, it is same as in the effluent from the reactor, and outflow is also referred as effluent. So obviously this is a miss. If while looking at the diagram you can say, and with some background knowledge, that yes, some pollutant will come here, there will be some kind of reaction, and it will achieve some kind of equilibrium, and then it will go outside of this out of my reactor. So this statement is true. So for more detail I will once again I will ask you to go to this book, and this is very much to discuss in chapter number 3, that is 47. Chapter number 3, mass balance studies. So they have started the chapter with mixed balance or well mixed lake or CSTR. So you can see the I have written this equation, but this there is separate equation for this accumulation, loading, outflow, reaction, settling, and from there the final equation which is derived is look like this equation: v dc by dt is equal to loading minus means mass in minus mass out. This represents some kind of reaction, and this represent some kind of settling. That pollutant might get settled on the surface of control volume. So again I will suggest please go through this book. Okay, I hope this is clear. So question two was around about CSTR. Again, I will discuss thing about there is a one again in upcoming slide. There is one more question regarding this CSTR where I will be discussing more about this thing. So coming to the second question, this is this is from your DO part, that is dissolve oxygen part. So just till now I was discussing about the mass balance, how some reaction is how the concentration of one pollutant decrease, and what kind of what kind of different reactors are there. That is well, there are different kind of reactors, but till now we have only discussed about CESTR, that is continuous stirred tank reactor. So in now there is one another thing, that is dissolved oxygen. So the question I will ask you to take a screenshot of this question. There is one wastewater sample whose volume is 4 and dilution water is 296. So just remember this why 296 ml has been taken. I will discuss. Then there is initial DO. Why initial DO? Then DO after 5 days, and there is degradation constant, that is 0.23 per day, and assume dilution water has no organic content. So the question is to find the BOD of the water. So before answering this question one must have idea what is this BOD. So BOD stand for biochemical oxygen demand. Remember this thing. There are many confusion that what is this BOD stand for. Sometime you must have heard somebody saying that biological oxygen demand. No, it's not. It's biochemical oxygen demand. This means generally people ask this thing, what is the full form of BOD, and actually we are dealing with this actually this BOD is related to biological things. So sometimes people tend to say that it is by biological oxygen demand, but it's not. It's biochemical oxygen demand. So, and what is this biochemical oxygen demand? So, this is oxygen required for decomposition of biodegradable organic matter. So, your organic matter consists of both degradable and biodegradable. So, whatever oxygen required, suppose you have some sample of water that will degrade with time. that will degrade with time. So how much oxygen is required to that degrade that organic matter and whose nature is biodegradable is referred as biological oxygen demand. Okay, so it is a wastewater parameter. So why I am saying it is a wastewater parameter? Because uh, water generally the water one water is for drinking water, one water is for uh, one water is wastewater. So this term is never used for drinking water. Also, if someone is asked that what is the drinking water parameter for drinking water limit, sorry, BOD limit for this drinking water, so you can say that there is no limit of BOD. Means BOD is not used for drinking water, it is used for wastewater. So if you have attended my previous session, I have discussed about this drinking water parameter with the help of IS code 10500 2012. So in that there is several drinking water parameter. So people tend to ask that what is the BOD in drinking water. So there is no BOD. We do not talk about BOD in drinking water. It is a wastewater parameter. So so how this BOD is determined to BOD is determined by measuring DO of the water. So and what is DO? That is dissolved oxygen. So to know the biological oxygen demand, what will happen that you will measure this dissolved oxygen. So what we do that we take our sample, there will be some initial dissolved oxygen, and we will keeping the same chemical for the same sample to degrade for say 5 days or 6 days, and again we will measuring DO for the next 5 days, after 5 days. So initially there was X diesel oxygen, and after 5 days obviously some of the oxygen will degrade this biodegradable organic matter. So after 5 days there will be a diesel oxygen. So the difference, that is X minus Y, will be our biological oxygen demand. Okay, so if you are not clear with this, just see the next slide, you will be getting more idea how this thing work. So and there is one theoretical miss. What will happen that obviously all the oxygen be all the biodegradable organic matter which is present is there won't be it takes infinite time. Theoretically it takes infinite time for the oxygen to decompose all the material. So what happened that these are some of the theoretical things that how this BOD work. So it is said that suppose if you have taken one sample in a bottle, and that bottle is known as basically BOD bottle. So what will happen that by 20 days period, what will happen that all the oxygen which is present there will degrade around 90 to 95% of the degradable matter, and in 5 days it will it will degrade around 60 to 70% of the your degradable matter that is present there. So the next question is how this dissolved oxygen is measured. So this is measured by agile modification method. So its complete name is Winkler's agile modification method, but in short we just say agile modification method. So again I won't be discussing this agile modification because it is again this method is in itself a very long lectures, around 1 hour 2 hour. So I will again suggest you to you can use any you can use your internet to search on this, and you can see how this method works. So I will be just discussing in brief that how this agile modification method work. So what happened that suppose if you are seeing any lake, and that has a dissolved oxygen, and that has dissolved oxygen around 8 to 10, then you can say that surface water is healthy water body, And how this dissolved oxygen measured? Again, this same method is used. There is another electronic method also. Nowadays what happened that there is an electronic probe which we dip into the sample and we can measure the dissolve oxygen. So that can give you directly dissolve. There is no need to do any kind of, you don't have to perform any kind of experiment. So but if this is a experimental thing which require titration and all these thing. So what will happen that so what will happen that you after and suppose if there is any kind of decrease from this normal DO value, then you can say that this water is polluted. So how can you say, how can you say that decrease in dissolved oxygen is suggesting that water is polluted? So how will how what is the reason behind that this DO will decrease? And the reason is presence of organic biodegradable organic matter. So what will happen that initially there was no biodegradable organic matter. That's why oxygen was not getting consumed anywhere. So all the present oxygen present in the system was in system only. But as soon as there is some kind of organic matter which pollute our water, so what will happen that organic matter will start consuming the oxygen, and that will result in degradation of that will indicate that this water is polluted, because that organic matter is consuming the oxygen which is present in the system. So what happened that to perform this experiment we are measuring DO. But what happened that we are measuring DO just to determine biological oxygen demand. So that's why this experiment is performed in BOD bottle that has a fixed volume of 3 ml 3 ml, so sorry, 300 ml. And this bottle looks like this thing. So there so in question it was there Naki, that we have taken 4 ml sample and 296 ml of dilution water. So to perform this experiment we need 300 ml of solution. That's why I have taken 4 ml of sample and I have diluted that sample. But why I have diluted because that sample may contain high amount of organic matter. So our result won't be I won't be getting good result, because uh, we know that this dissolved oxygen which is present in my sample will be less than or equal to around 8, and with time it will obviously decrease. So after decreasing from 8 to 10, suppose it is initially 8 and it has decreased to 6. So what will happen that only 2 milligram of oxygen has been consumed. So means we can say that the organic matter which were present there were very less. But now imagine you have very large amount of organic matter in that sample, very large amount of organic matter. So what will happen that within 1 hour or 2 hour or within 1 minute, what will happen that your this 8 gram will come out to be zero. And we perform this experiment for 5 days. Why 5 days? Because this is chosen this is a standard method. And the reason is that this statement is reason. This is the reason that within 5 days what will happen that the 60 to 70% will be getting degraded. All the organic matter will be degraded. Sorry. So that's why we have chosen a 5 method. So what will happen that this 5 method is this 5 day experiment is done everywhere. So again, miss, what happened that how much you have to dilute? All this depend upon the chemical oxygen demand. So again, before performing the experiment of this DO, what you will do that you will do one experiment, that is chemical oxygen demand. And depending upon the value of chemical oxygen demand, you will perform the experiment of BOD or uh, oxygen dissolve oxygen, yeah, BOD experiment. So how much dilution has to be done, how much dilution you have to do for how much what value of COD, there is one chart given in one book. I will also share that book. I will just refer that book also after this slide. So what happened that and the how depending upon the COD value, you will dilute your sample, and the dilution factor will be given as total volume, and total volume will be always equal to 300 ml, and the volume of the volume of sample, whatever you have taken your sample. So in our case, we have taken 300 ml of total volume. For this BOD experiment, this is general formula, but for BOD experiment, this dilution factor, this total volume is always 300, and the volume of sample keeps changing. So for our case, it is 4. So that dilution factor will be 75. So what will happen that how this BOD is determined. So what will happen that I will measure the initial DO of the sample and the DO after the 5 days, and whatever there will be depletion in the dissolved oxygen content multiplied by the dilution factor will give our biochemical oxygen demand. Okay, so what will happen that initial DO will be measured via agile modification method, and for 5 day BOD, the sample will be incubated at 5 days at 20 degrees Celsius. So this temperature and this day is referred as a standard temperature and a standard day for conducting this BOD experiment. So remember, you are obviously, what will happen that you are diluting your sample with some kind of water. So there can be a question that what if that diluted water already contain some organic matter. So to avoid that question, we also along with the sample, we also measure the DO of the blank sample. So what is blank sample? Blank sample is that water that you have used for dilution. So blank sample is the water used for dilution. Sometimes it is also referred as dilution water. So what will happen that after 5 days, again you will take out your samples, that is sample and blank, and you will perform experiment. And after experiment, you will have, after 5 days of experiment, you have these 5 data, that is initial DO of the system, DO of the sample after 5 days, initial DO of the blank, DO of the blank after 5 days, and that will be represented as DOI, DO5, DO blank initial, DO blank 5, and dilution factor that you have diluted. So, so what will happen that what will happen that this BOD, and the BOD will be the which will be coming from this experiment will be as milligram per liter as oxygen, and the equation will be what I said. You have initial DO and you have the DO after 5 days, and what so this is like miss. What is this giving? You have from this equation you are getting means you can refer that there was some initial DO, and the initial dissolved oxygen present X amount of oxygen was present. With time, after 5 days, what happened that all the organic matter was decomposed by oxygen present in system. So what will happen that the amount of oxygen will be decreasing. So this DO5, you will be getting some value of DO5. So difference of this thing will be giving you this BOD, means how much oxygen has been consumed in degrading that matter. Okay, and I have also there was assumption means that our blank means our dilution water might some contain some organic matter. So what will happen that I will be subtracting that I will be subtracting the amount of dissolved oxygen present in the blank and into the dilution factor. So this will give you the overall BOD of your sample. So again, I have missed one point that why this 300 ml sample is used. So what happened that so suppose someone is working in wastewater treatment plant. So what happened that they have one very simple task, that they have to measure this DO of the sample very regularly. So what happened that the person who has designed this experiment, they have designed experiment in such a way that a person or a engineer who is working in the who has to measure DO, he has not he should not do any experiment, just perform the experiment and give the what is the value of DO. So this 300 ml is chosen in a such a way that what will happen that you put there are two reagents required in this experiment. First is MnSO4, that is manganese sulfate, and the second is azide, alkali azide reagent. So what happened that you take 300 sample, we have to add only 1 ml of that, and 1 ml of, sorry, 1 ml of manganese sulfate solution, and 1 ml of azide solution. So this will and 1 ml of, there is indicator which is used in this indicate experiment is a starch indicator. So as soon as you will add the starch indicator, what will happen that this system will turn into blue, and we start titrating it with some reagent called hypo, yeah, sodium, what is the name of, I'm just forget, we generally called it in a general term hypo, but so it's sodium, just 1 minute.
Sodium thiosulfate.
Sodium thiosulfate. In general term, we represent as hypo, means hypo we say when we do perform. So what will happen that this whatever amount of hypo is consumed in titrating in achieving the blue end point of this reaction, that is from blue to colorless solution, that will be directly your DO of the sample. So that's why this 300 is chosen in a specific way. So after 5 days you have this data. You can put your value in this equation, and you can calculate the BOD of your sample. So coming to the our question is that the initial DO was 7.65. DO after 5 days is 4.2 milligram per liter. Remember, it is written milligram per liter, and it will be as O2. Okay, now. So how miss there is separate derivation, how how we derive this equation. Okay, so in DO after 5 days it will be 4.2 milligram per liter, and already in the equation there was one statement that your dilution water does not contain any organic matter. So the DO of blank will be 0, and the dilution factor already said it will be 300 divided by 4, that is 75. So I will put all the value, and I will be getting that BOD. After BOD, I have forget to mention there will be a 5 BOD 5, because I am calculating BOD after 5 days. Similarly, there will be a BOD after 7 days. Someone can also calculate the DO after 7 days, and he can report the BOD 7. Okay, and so the answer will be 258.75 milligram per liter as oxygen. Remember, you have whenever you are presenting the answer of BOD, make sure to write the unit milligram per liter as O2. Okay, I hope this is clear. So coming to the second fourth question, estimate the ultimate BOD of the water. So now you know there was one statement that s- I, there was one statement, this bio BOD, yeah, biochemical oxidation is slow process and theoretically takes infinite time to go to completion. But still someone asks you to miss what will be the ultimate, this what miss after, suppose if I perform experiment for very long time, so what will be my ultimate BOD? Because infinity time, achieving infinity time is not possible. So there has been some method developed for calculating this BOD in theoretical way. You have to do experiment. Miss, you have to find the BOD 5 value. Then with the help of this BOD 5, you can calculate the ultimate BOD. So So everyone know that the degradation of, so I will derive that what kind of equation is used for estimating this BOD. Okay now, so everyone is familiar with this concept, that degradation of organic matter is according to the first order reaction. Okay, so again, if it is a first order reaction, you must click, you can either directly write the equation. If it is a first order reaction, then you can directly say that the equation which I have said, that C is equal to initial concentration into E minus KT. Okay, but you can derive also. But what happened that when I am deriving for C, then we say that C is equal to this concentration. But when we have to do, when we are driving the equation for BOD, we have to take some kind of assumption also. So obviously this is according to the first order reaction. So what will happen that the change in concentration, and what is this LT? LT is the remaining BOD. Okay na, remaining spelling is incorrect. So so what will happen that this is remaining BOD. So what will happen that there will be some kind of initial BOD. With time, your BOD will be decreasing. So at time, at any time, this will be representing as, this will be the equation will be change in concentration of this remaining BOD will be equal to minus K into T, and your again initial condition will be by at T is equal to 0. You will be have your what, see how this this L naught is represented. L naught is your ultimate BOD. So what will happen, see, initially what will happen that your sample contain all the oxygen. So that is your sample contain all the oxygen. So whatever amount of oxygen that is required, after 5 days, after 10 days, after 15 days, what will happen that your organic matter that is present in the system will be decomposed with the help of that oxygen only. So this L naught is also referred as ultimate BOD. So LT is your remaining BOD, and ultimate, this is your ultimate BOD. Again, I will be deriving the equation, same method you have to put, and you will be getting this LT, that is LT is equal to L naught minus KT. So now the second thing is that now we have to find at BOD at any t time. So what was happened that this was ultimate BOD, which is L naught, and after 5 days, what happened that there was some reaction, all the oxygen was degraded. So so there was the remaining BOD is LT. So after subtracting the initial value with the concentration or remaining BOD at time, you will be getting what is the BOD for that period of time. So this is also referred as exerted BOD. BOD at any time t uh, that has been exerted. So this BOD is calculated experimentally. So what? So just try to relate both experimental thing and this theoretical thing. So from experimental we have find BOD after 5 days, and from theoretical we are calculating two things: remaining BOD and ultimate BOD. Ultimate BOD he also experimentally ultimate BOD is not achievable because it takes infinity time to complete. Remaining BOD, again same remaining BOD is also not able to we cannot calculate experimentally. So that's why we have generated this expression in terms of ultimate BOD, and only thing which we can calculate is BOD for some particular time. So this will be LT minus LT L naught minus LT, and LT we have already derived the equation for LT, and if we take out L naught, the final expression will be this thing. So the question was estimate the ultimate BOD. So you have already calculated BOD after 5 days. So I will be just correcting one thing here. It will be 5. Okay. Hmm. So I have already calculated the BOD after 5 days. Just 1 minute. After 5 days, and after 5 days from the experiment it's come out to be this much, and K is also given. This K is already said that degradation constant or simply rate constant. Okay, so and how much day for this equation time will be 5 days. So I will be putting all the values here, that is 258.75. This was calculated experimentally. I have to calculate L naught. After putting all the value, you will be getting L naught is equal to 378.68 milligram per liter as CO3. So if you perform this experiment for very long time, say 1 month, 2 month, which is very tedious work, because you have to wait for 1 month and there might be some another problem. So you won't be able to achieve this BOD, but you will be near to this thing. Because what will happen that during the when you will be performing your experiment, what you will be getting, you have this equation. So after a long time, what will happen that this will go to zero. But the theoretically, yeah, experimentally, this will never miss. What will happen that there will be some miss. It's very long. It's taking very long time to achieve this term zero. So experimentally we cannot calculate. So what happened that we have calculated theoretically. So theoretically, what is nothing, just dilution factor into this initial DO. So somehow they have miss. It's not directly related. Miss, they have tried to express in the terms of first order. They use the concept of this first order, that we know that organic compound decompose in first order. So they have tried to develop some equation depending upon that thing. They have developed this equation. I hope this is clear to you. So I will be just discussing fifth question. Again, we have come to this mass balance thing. So before going to the this and discussing this, I will be discussing sixth question, that is related to this wastewater only. So I will come back again to this question. What do we call fifth question? But before discussing that, I will be discussing, because I am already discussing about wastewater. I will be doing. I will continue with that. So a question is that a wastewater stream is mixed with a river nearby. After mixing, formation of certain zones occur. Which of the following zones are characterized by highest level of treatment of any pollutant? So there are four zones: zone of degradation, zone of recovery, zone of clear water, zone of active decomposition. So before answering this, I will be discussing what is different type of this zone. So what happened that the first question is why this wastewater is being dumped in river. So what happened that it has been seen that the river has self purification mechanism. So what happened that people dump their wastewater in river, so that with time, as river has healing mechanism, so it won't affect the river. So what happened that sometimes if people do not miss this is general statement, but the problem arises when this wastewater is too much contaminated. Now just imagine that you have dumped a wastewater which contain very large amount of um, organic matter, and which is very much polluted. So this self purification will also not work. In this manner, what will happen that your river will get polluted. So that is another scenario, but you should remember that why somebody will ask that why do we dump our waste water in river. So because it has self purification mechanism, but that is also up to some limit only. If it is treated wastewater, yeah, some miss some preliminary treatment has been done and then it is done, then it is okay. But if it's too much polluted, then that will, this self purification won't work. So this self purification is a complex process that involves action of physical, chemical, and biological process. So there are different kind of processes which occurs in the system, in the river, and that um, the river get purified, even though there is some kind of dumping of wastewater. So coming to the different zones, so what will happen that there will be some discharge. So some factory or someone is discharging your wastewater. So for some initial length of the river, consider this is a river and the flow is from this direction to this direction. So what will happen that initial zone where this has been discharged, or the wastewater has been dumped, will be called as zone of degradation. And after some time there will be zone of active decomposition. What is this zone of degradation? I will explain those things. After some time there comes some zone of recovery. Here what will happen that whatever there has been some loss, the river will try to recover that. And finally the zone of clear water means here, even though we have discharged, we have dumped it, but after some length, say may 5 kilometer or 2 kilometer, you will get clean water. So this, the concept of this different zone is explained via this oxygen sac curve. Before discussing oxygen sac curve, I will discuss this different term. That is what is this ZOD, that is zone of degradation. So what will happen that this will, in this condition the water will be dark and turbid because you have already dumped your wastewater. And there is something called rate of deoxygenation and there is a rate of reoxygenation. Deoxygenation means what is happening that obviously this wastewater will be this wastewater will contain some organic matter. So what will happen that this water will this organic matter will start consuming your oxygen present in your system. So this is called when there is a decrease in oxygenation. So what will happen that it is deoxygenation. And obviously we know that there is something called concept of aeration in the river. Obviously from the atmosphere oxygen comes in the contact of the water and it gets dissolved. So that is called reoxygenation. So what will happen that this rate of deoxygenation, yeah, not only this oxygenation for oxygen from air, oxygen that is present in sorry, oxygen that is present, that is we know that there are algae is present there. So that also do photosynthesis and produce oxygen. So that will also help in just concept, remember the concept of aeration. So what will happen, this aeration will again provide some kind of oxygen. So what will happen that the amount of oxygen coming in the system is very less as compared to the amount that is being degraded by your organic matter. So the characteristics of this zone of degradation is that water is dark and the oxygenation is very high. The second is called zone of active decomposition. So um, what will happen that the organic matter which was present in the system will start consuming oxygen first. Now what will happen that with degradation the water will become more darker and more turbid, and the DO of the system, what will happen, the organic matter which was present in the system will consume all the oxygen which was present there. And this will make the system, this will make the river having du equal to 0. And what will happen that anaerobic condition may rise to may be present there. So what is anaerobic condition? That is organic matter will be start consuming, that is attached to something, that is. So first you should know what is anaerobic condition. Aerobic condition is the consumption of free oxygen, and anaerobic condition is consumption of oxygen which is attached with something like SO4, yeah, NO2, something like that. So what will happen that the free all the free oxygen has been consumed. So what will organic matter will start to extract oxygen from sulfate, yeah, something that is not the oxygen which is not free. There is very wrong conception that aerobic is in presence of oxygen and anaerobic is in absence of oxygen. This is wrong definition. Just remember, aerobic is in presence of free oxygen, and anaerobic in presence of attached oxygen. That is oxygen when the free oxygen is not available. What will happen that organic matter or bacteria will start consuming oxygen which is attached to something like SO4. So as soon as now just imagine now from sulfate, yeah, nitrate, yeah, anything, you are extracting oxygen. So what will happen that this will start oxygen will be removed. So in sulfate will get converted into sulfide gas, and that's why what happened that your river will start smelling. So sometime in your home also you can imagine that your waste started to smell. Why it started to smell? Because what will happen that you if you have done if you have thrown some organic matter, so what will happen, the bacteria will first consume this free oxygen that is present there. Once all the free oxygen will has been consumed, so the organic matter has to be degraded. So what will happen that it will start consuming the oxygen in the that is present in the form of sulfate or nitrate. Okay, so in that way, and that will start to release of some gases, and in that way your waste um, the waste, yeah, wastewater started to smell. So this is more heavily polluted. The reason is due to this only, because all the oxygen has been depleted. But after some time you will start getting cleaner, because all the system, all the kind of reaction which was about to happen has completed all the degradation. So what will happen that this amount of deoxygenation was there, but you were also providing oxygen from the surface, yes, from anywhere, from the surface obviously. So this rate of deoxygenation will be less, and rate of reoxygenation will be high. So that is known of zone of recovery, and finally the zone of clear water, that is river in the original condition. This was a concept of different zone. Okay. So I coming to this oxygen sac curve. So depending upon the amount of dissolved oxygen present in each system, a model has been generated that is referred as oxygen sag curve. This expression has been derived with by first via experimentally, because some engineers must have done, they have collected water from here, and from here, and they have plotted the graph. And this has been also modeled with the help of this, again, first order reaction and all this thing. So there is fine derivation about this. You can search about this oxygen sag curve. So it is plotted between the dissolved oxygen and the distance. So what will happen that initially what will happen, there will be some kind of river has some kind of initial saturated DO. Your river is always saturated with some kind of DO. As soon as dumped is some kind of waste is dumped here, so this DO will be start decreasing. It will keep decreasing, decreasing. So it is said that at the point where the DO is 1.0.4 of saturated DO, that region is known as zone of degradation. And what will happen that after some time, it the your this DO, obviously what will happen that already said that the organic matter for degradation, that this DO will keep decreasing till all the organic matter has not degraded. So what will happen that at this case you can see that dissolved oxygen has nearly reached to the zero. And as soon as this step has all the system has been degraded, all the organic matter has been degraded. So with distance, again your river will be getting your original will be achieving its original condition. So this is overall oxygen sag curve. So you should look the derivation of this is very nice curve, and the modeling and the derivation is really nice. So this is called critical time means, obviously I have plotted with time distance, but obviously the decrease in oxygen has happened at some time. So but you can find this critical time at what time. So what will happen that this river will have some velocity at which yes, you can say some discharge. So you know discharge, you know this area, so you know the velocity, and you know you have this distance means after this time. So you can calculate means by finding at what time, at what distance, what kind of diesel oxygen is present in your system. So you should look into this thing. Okay. So the correct option, the question was which is the most polluted. So that is zone of active decomposition. I hope this is clear. So the coming to the uh, seventh question, that is this is a BOD. So so what happened that there are two kind of BOD. So two kind of BOD, that is carbonious stage and nitrogenous stage. So what will happen that organic conversion of organic matter to O2. Okay na. So obviously what will happen that this huh. So what will happen that this organic matter, what does this organic matter mainly consist? That is carbon only. Okay na. This will be CO2, not O2. Conversion of organic matter to CO2. This type of mistake. Hmm. So what will happen that this organic matter will what will happen that all the carbon which is present in your organic system will first get converted into CO2. So that is first stage of BOD. So experimentally what happened that we only find this carbonious BOD only. Finding this nitrogenous BOD is different method. So the method which I was saying, that azide method, they find generally this carbonious CO2 only. So what happened that once all the carbon has been consumed, so not all carbon, some carbon, means say around 60 to 70% has been converted into CO2, then that stage will be known as carbonious stage. And the second step is the nitrogen get converted into different form of nitrogen, suppose NO2 or nitrous, something like that. And along with this there will be some decomposition of organic carbon also, but that will be very less. So that the first step is where the conversion of organic matter is into CO2, that is known as first stage of BOD. And the second stage which is in which nitrogen gets converted into different form is known as second form. So the question is second stage of BOD in figure due to this is due to nitrification demand. So again, sorry, there is a mistake. Hmm. Okay, so I hope this is clear to you. So to read about this BOD and COD, I will be referring you this book. I hope you might have read it, but if not, then chemistry for environmental the chemistry for environmental science and environmental engineering and science by McCarthy and Sawyer and McCarthy. This is very famous book, Sawyer and McCarthy. Sawyer and McCarthy. People, whenever some kind of experiment is done, people refer that which kind of book you have to refer, Sawyer and McCarthy. So So after chapter number 11, this experimental part start. So here you can see that from basic concept of this qualitative chemistry to color, standard solution, turbidity, and around this chapter number 22 is of dissolved oxygen, that is on 624, around 624. No, it is. So biological oxygen demand. So here you I think I will suggest you to read this book, starting from here. This is oxygen demand. So first oxygen, sorry, dissolved oxygen. A detailed way how oxygen is in different form of water. Sorry, different in how this different water body has what kind of dissolved oxygen, and how the variation of DO affect our system. It is given in detailed form. So here first they have discussed about this dissolved oxygen, then this BOD. So I was telling you one thing na ki miss we dilute our sample as per our uh, uh, sorry, as per our value of chemical oxygen demand. So that is also given in this work only. So we whenever we do experiment for wastewater, we refer this book only. So if we go to 21 chapter, which is so I'm not going to search about it, but when you will read this book, you will find it like that for what value of COD, how much dilution you have to do for finding your diesel oxygen. So please uh, make sure that you this book is also again also available on the internet. You can download it from internet by searching chemistry for environmental engineering and science by Swan McCarthy PDF. You will get this PDF. Okay. So till now all the questions were related to BOD and COD. Hello. Sorry for the inconvenience. There was some internet issue. So sorry. I will start sharing the screen now. So till now, I hope whatever I have told you, you have understood it. If you have any question, you can ask. So is my screen visual? Please confirm. Hello. Yes, thank you. So till now I was discussing about this thing, that is BOD, dissolved oxygen, and BOD. So these are wastewater parameter. Both DO and BOD are wastewater parameter. These are not used for drinking water. Drinking water parameter. Okay. So coming to there was one question that left. This match the following, that you have to match different kind of batch reactor, different kind of reactor out of these three options. So there is batch reactor, PFR, CSTR. So batch reactor I will discuss by PFR, that is plug flow reactor. I will discuss this thing only. CFSTR, that is continuous stirred tank reactor, I will discuss. And the option are reactor in which fluid flow in such a way that these are different options. So I will not based on. I will go. So first I will discuss about this. What is this batch reactor? So this batch reactor is nothing. You take one system, you take one vessel, and you add some. Take some. Just I will show you final photo. This is a batch experiment. Yeah, for batch reactor. So what I have done that. Uh, so what I have done, I have just taken one beaker. I have added some water, and I have added some chemical, and I have done some experiment. And with time I have taken some samples, and the example which I have shown you about different for the for finding order of reaction. I have that reaction was done in batch, that was done for batch reactor only. So this is a batch reactor. So this is a most simplified method of doing experiment. Simply you take one beaker, you perform some you add some water of your concern, you add some chemicals, and with time you take your reading. How we take reading? With time be a stop, and this is magnetic stirrer. There is one magnet is kept in the middle of this system, and it is rotated at say 50 rpm, yeah, 100 rpm. Yeah. Generally the most common general rpm which is used in experiment is 110 rpm. So that will be, it will be kept here, it will be rotated, and for taking reading we use some kind of filter. We take out sample and we store it in a storage. Sorry, we store it. So this is point about this batch reactor. This is a most simple straightforward method, will be involving a pollutant into several. So you can see that for same experiment I have done, I have taken, sorry, uh, different type of concentration, this thing. So the vessels are this. So this system is known as batch reactor, and by monitoring the concentration of each bottle over time you can gather the data relationship between time and concentration, that which I have shown you earlier. So this was done for batch reactor. Okay. So this is, if someone asks you what is batch reactor, so you will say that we take a vessels, we add water of our concern and chemical, and we take reading with time. So the point which is here to be noted, that there is no kind of flow here. All the water is in here only. The miss, if you remember CSTR, what was happening? The water was coming to the system, then it was going. But here there is no such thing. Water is already present here. With time, I am just taking reading. So if I wanted to match, uh, if I wanted to this do, sorry. Hmm. So if I wanted to match which of the following, so this is a there are four options. So batch reactor will be matching with these two. Reactor with no mass flow into or out of the system, means that system is there. Only you are taking reading at different time. There is no incoming, no outgoing. Is that clear? I hope it is clear. So the first will be matching with the reactor with no mass flow into the or into or out of the system. Whatever is there, it is present here. With time you will be taking the reading and you will be noting down in Excel sheet or in your copy. The second is plug flow reactor. So the whatever I have written down here is all of the statement all is taken from that book only. If you are not clear, suppose I will try to explain you each and everything, but if you still you are not clear what is are those things, you can go and check that book. Each and every in that book, the things are described in more advanced way and more detailed way. The plug flow is one which in advection dominates. So uh, I will show you what is the first plug flow. So what happened that this is a representation of plug flow. Means plug means, just remember what is plug. Plug means at there is one suppose water is flowing from A to B, and there is one middle point. Suppose water is moving from A to C, and there is one middle point B. So what will happen that you will be sitting at C and you will be checking that at C what is happening. So you are not concerned about the water that is before C and what is after C. You are just concerned about what is happening at that point C. So it is kind of plug. Means a plug of water is coming at C. You are analyzing that and that is going away. A water of again a plug is coming at that point A. Again that is going. So you are just concerned about that thing and nothing else. So how this advection dominates, I cannot explain it right now. For again, how in this PFR how this advection dominates, I will suggest you should look into that book. You will get a clear picture how this advection and what I have explained, that I am looking at point C and how what is coming and how what is going. Okay now. Miss, overall, the summary of this thing is that in water, substance is discharged in the same sequence as they enter the reactor. So, what will happen? That you can see that this is C. This is there is one concentration C. So, it is going as it is in the system. So if we match the option B, a reactor in which fluid flow in such a way that fluid reactants are not mixing along the direction of flow of the fluid. So along the direction, what is happening that so again remember this thing. So this will happen. What will happen that this will be spread all over the time, all over the all over this system. So if you look at this in the direction of the system, what you will see that along the direction of the system, along the direction of fluid, there is no change in concentration. From this graph you can see. uh, huh. So you can see. So the second option match with the this is a reactor in which fluid flow in a such that the fluid reactor are not mixed along the direction of the fluid flow. Coming to the this second thing that I have already discussed with you. Coming to this CSTR thing, which I have already discussed, like this is a most common way to model our lake, river, yeah, any kind of experiment. So whenever we are batch experiment is the most simplified experiment. Generally, very few research is are there on a PFR, but most of the research which is going on, yeah, most of the question which comes is about this CSTR or this batch experiment. PFRE also, if you have a pair, if you are appearing for the GATE exam, then question related to the CSTR and PFR comes. So what is this different kind of numericals? You should see that in that book, so you will get a brief idea that how this different kind of reactors work. So coming to this CSTR, it is among the simplest system that can be used to model a natural water body. So consider this lake as a natural water body. So obviously we want to see that how this um, how a pollutant, how or how a wastewater is behaving in. Just 1 minute. I have got cramp in my leg. Just 1 minute. So so if you will go through that book, you will see that most of the examples are of lake. A sample is going to lake, or a waste has been dumped in the lake, and most of the question will be according to lake. And basically that book will also give you an idea how to treat a lake, how to treat a river. Because if someone is doing research, yeah, you are doing research, then our final aim is to treat something. So if uh, so any environmental um, researcher, what they do, that they just work on that thing, like I have to get the basic idea how a pollutant enters into the system, how they react, and what will be the final concentration. And most of the system is CSTR, that is continuous stirred tank reactor. So by name also you can see that in our system what is happening. Water is coming, there is kind of some natural mixing, and that is going out. Yeah, that is in the system only. So that's why it is, this CSTR is the most common reactor, and one should have, if you are interested in environmental engineering or water treatment, then you must have this idea of this continuous stirred reaction, the stirred tank reactor. It is among the simplest system that can be model a nature used to model a nature water. See, I am using this model. Miss, you should understand why I am using the term model, because I am not here to experiment in natural water body. Because performing experiment on this thing, a big lake, is impossible, and you have to invest too much. You cannot perform experiment every time, because performing experiment takes time, takes your resources, take chemicals, and chemicals are very expensive. So what do you so you, if you are planning to treat something, so first you will model that thing. So what you will be doing, maybe you have to do experiment, but you will be doing experiment for some limited point, say here at the loading. And suppose if you are doing experiment here for, suppose, say 5 or 6 time, and then you will be taking some, doing some experiment at the outflow. Based on that data you will model. So till now whatever I have shown you, the equation of zero order, first order, second order, miss, how do miss, what do you miss, how do you interpret that equation? Either that equation was first developed or the experiment was first done. So remember, always the experiment was done first. So people realize that there are several kind of experiment in a same manner. So there is no need to do same experiment again and again, because that will uh, waste your time, waste your resource, waste your energy. So what they have done, they have modeled everything. So by the model, with the help of modeling, you can interpret anything, that after some time the concentration of this will be this much after. Because suppose you want to measure concentration at 1 minute also, and 2 minute also, and 1.5 minute also. So you have to do, see you have to take 3 readings. Now just remember, you are taking first reading. Obviously you cannot take reading in 1 second, it will require some time. At that time only 1.5, your 1.5 minute will arrive. So what do you have to do? You cannot do, miss, this will be very tedious work, just as simple as that. So what we have do, that we will measure at 1 minute, we will measure at 5 minute. I will model that data, and I will predict what will be the concentration at different time interval. So that's why I am using the term model, not experiment. It is appropriate for receiving water in which water contents are sufficiently well mixed to uniformly distributed. So this system contain, what we assume, that suppose if there is any lake, The water is uniformly mixed. Such characterization is often used to model natural lakes and some of the impoundments. Means lakes and all these things. This is similar to first statement. So if we match third option, it will be CSTR will be matching with homogeneous reactor with mass flow into and out of the system. There is mass flow, there is mass out. Okay, this mass flow, mass out can be equal to zero also depending upon the condition. So for that again, I will suggest that please refer to that book. That book is like for modeling. That is the best book available throughout the world. In India, yeah, if you are doing research outside India, everywhere people use that book. In different college also, people suggest that book only, that because that is most simple book in most simplified language. Okay, so the coming to the last portion, I have already discussed this thing. 6 number question, 7 number question. Again, there is one interesting question which is very long question. So in a batch reactor, again see batch reactor account. An experiment was run in the lab to improve propionic acid. It is a common organic acid that is used in production of various chemicals that is often present in the system. As soon as you see this propionic acid, this is a organic acid. So first thing you should click that it will follow first order reaction. And first order reaction follow the equation C is equal to C naught E minus KT. Miss, by reading question you should start imagining that what is going on. Okay, you might miss. I'm just discussing it, and remember these question are present, are also this similar type of question is also given in your assignment also. If you are doing the assignment of NPTL, yeah, there will be a final exam. So this type of question you can expect in your examination. Okay, so initial concentration is 21 milligram per liter. Concentration of after 30 minutes is 3.5 milligram per liter. Assume that can be produced by this. It is already written that first order. There is no need to assume. Organic, most of the organic things uh, decompose via first order only. If this equation was not given also, then I could have assume that it is a first order reaction and assume a steady state. Steady state means whatever the water is coming in your system, they have achieved equilibrium, means concentration is not now changing. This is a steady dcd. I have said that dc by dt is will be equal to something. Now suppose a steady state has come, yeah, equilibrium condition has come. Remember I am saying equilibrium condition, but there is different meaning of equilibrium condition and a steady state. Just I ask for you what is the difference between a steady state and equilibrium condition. Just I'm saying at equilibrium condition dc by dt may not be zero, but this at a steady state dc by dt is equal to zero. Means this rate is not changing. But equilibrium condition is different. Means A is forming B, at same time B is forming A. Means that there is equilibrium in the system, but at the same time there is change in concentration of A, and the rate of change of concentration of A is equal to the rate of concentration of change rate of change of concentration of B. That is equilibrium condition. Okay, so for your own curiosity, you should also know that what is this steady state and equilibrium condition. See, I am speaking many things, so it might have happened that I might have spoken it wrongly. So if you feel that I might have spoken something wrongly, so please do check it. I will miss. I have tried my when I was doing practice of this thing. I have tried that I won't speaking. I won't be saying anything wrong. But suppose I am also a student, only a PhD student. I might also do some mistake. So please make sure that wherever you feel that I am saying wrong, note it down, do check it, and please correct that. If I am saying something wrong, you can interrupt me in the middle of the discussion also. Okay. So the coming to the first, this is a common question for question number 8, 9, 10. That initial concentration is this, question concentration after 30 minutes is this. First order you have to follow. So you have to answer some question. Estimate for the given information, estimate the rate of reaction. So this is very simple question, that as it is first order reaction, so again I will follow the same method, and I will be coming to this equation. You have to find rate of constant, that is k. And remember, this is the graph of, I have shown you. I won't be discussing because only 10 minutes are left. So you are familiar with this graph, what is this r square and equation. So now, there are two methods. Actually, for this graph I have only two data, so that's why I cannot plot a diagram like this. And suppose if you compare this graph with this equation, you can say that your by will be lnc naught will be this term. So you will be aware of initial concentration, and your kt t is equal to x, and your k will be this thing. But this graph is not related to that question, just remember. Okay. So but if you have several data, then just you don't have to do this kind of work. You have to integrate, just you can plot the diagram, you can compare this equation with this equation, and you can say what is the value of rate constant directly. But I was having only one single data, that is initial data and final data at 30 minutes, so I will be using this equation. So for our question, what is C? C is equal to 3.5 milligram per liter. C naught is equal to initial concentration is 21 milligram per liter. Time is equal to 30 minutes. What will be the K? So ln C is equal to ln C naught minus KT. I will put the value here, and after substituting every value, I will be getting this K is equal to 9.95 into 10 to the power minus 4 second. The answer was asking you, they were asking you to report in this second, but in a minute it will be k is equal to 0.0597 per minute. Just remember the unit. Just remember one thing. This, so initially when I was discussing this thing now, rate of constant, where it is, this thing. So just remember, for each and every order of reaction, the unit of K is different. Sorry for this inconvenience. Am I audible? Sorry, actually I don't know what's happening. But just remember, for each and every kind order of reaction, the unit of K is different. Here the unit of K is only, here is the unit of K is milligram per second. Yeah, mass per time. Here the unit of K is per minute, yeah, per time. And here the unit of K is 1 divided by concentration into mass. Concentration will be in term of mass only, mass into second. Just remember this thing. And generally C is this C concentration is how it is generally referred in the term of milligram per liter, या mole per liter, या molarity. So depending upon the unit of C, the unit of K will change. But this is very, just don't assume that everywhere K is same. I am writing rate of constant, but at same time the unit is different for all these three. Okay. Hmm. So for this for the first question where they were asked to find out K, you will put the value and you will be getting your answer in 0.0597 per minute, and that is 9.95 into 10 to the power minus 4 per second. Okay. So coming to the second question. Now they have used same data but for a plug flow, that is calculate the hydraulic retention time. Hydraulic retention time is nothing but time for which you have how do we define hydraulic time? Residence time means you have your batch reaction. Yeah, you have your control value for how much time that reaction has happened, and after that you have taken out your sample. That is hydrolytic retention time. So it is if you are not clear with the definition, you can refer to that book. So hydrolysis achieve the effluent concentration of 1.5 milligram per liter with same initial condition. Okay now. So here see, what will happen that there is two option. Means already say that it's already in question. It's saying that there is a batch reactor and that is following first order. So you can directly apply this equation c is equal to c naught. From this equation, what you this equation, you have find out your k. Okay. So for this equation now you know everything. So now what they have changed this system, and they have just changed another data, that what will be this one, the initial the final concentration is now 1.5. So in this equation lnc is 1.5, c naught you already know that is 21. They are saying that initial condition is this. So you have to find t. So either you can use this equation. So that will be a little bit lame work, because if you are appearing in some examination, you can do directly that thing. But suppose this is a theoretical exam, and if they have mentioned this plug flow, so the plug flow has some condition that it follow advection, the concentration going for a particular time, it will be same, such kind of thing. So depending upon that thing, you have to derive formula for concentration variation in pfr. Okay now, because in pfr what we have seen that we are giving the importance of concentration with distance. If you have given, if you have seen this graph, see here concentration, and we have given the importance of x. Obviously this water will be flowing with some flow rate. Suppose say that velocity is v, and if you have given, if you have given some, if you are provided with the distance, you can find this, what will be the time, that is distance divided by velocity. Okay. So the two terms are defined, that is flux. That is flux is given by velocity into concentration. If you are not familiar with this equation, no problem. But this is how flux, you everyone is familiar with the flux. You must have read in class 10th, sorry, 12th. What is flux? So water flowing through a particular unit area, something like that. So what will happen that the flux for pfr, we derive two terms, that is flux in, flux out, and it is derived in a this way. So and already said that the order of reaction in minus kvc, and this is mass balance equation. This is miss. I have not discussed it previously, but I hope most of you are familiar with this equation. That is v dc by dt is equal to mass in minus mass out plus minus some kind of reaction. So that can be modified in the form of mass in will be flux in, mass out will be flux out, and that will be plus minus reaction. So again substituting every value v dc by dt, this mass in that is flux in is equal to velocity into concentration and area of that particular area. So see, remember what will be the mass in, whatever the mass, that is equal to discharge into concentration. Discharge, what is the unit of discharge? Discharge has unit of meter cube per second. And what is the unit of concentration? It is milligram per liter. Yeah, milligram per meter cube. So meter cube will be get cancel out the mass which will be there. It will be milligram per second. So that is also mass. So this the unit of this thing is similar to mass in. Okay now. So remember in this whole thing, whenever you are writing mass balance, make sure to you are writing in a correct way. And correct way to check that you have written your mass balance in correct way or not, by matching this unit. So here at each and every place you can see that unit is in unit is same everywhere. Okay. Hmm. Unit is same everywhere. Yes. Hmm. So if we put this value and obviously this term and this term will get cancelled out, you will be getting this final term as this, and divide the both side by v, and as this delta x will be very small, so your final equation will be this thing. And again I have said, as the condition is saying that at a steady state, so this dc by dt will be equal to 0, so you will be having your final equation, this thing. Again you will do the integration at t is equal to 0, t is equal to 0, c is equal to c naught, and again you will do integration like first order reaction, and you will be getting this equation, that is c is equal to c naught e minus kux. So this is the equation for plug flow reaction. Okay. See, now I will see you. So why did I tell you that for you are giving experiment, any exam, numerical MCQ exam, you can use directly that formula, but theoretical, because in if you are doing theoretical paper, then people are expecting you to write this equation, and from this equation, and now the initial the concentration after, you have to find after how much time the concentration will be 1.5, initial concentration is this, and you have already find out the k value. So now just remember how we compare that equation, first order reaction, yeah, batch reactor equation with PFR. So we know that velocity will be given by distance upon time. So what will be time? X upon u, and in this equation I can substitute x upon u by this t thing. So your final equation will be same as what you have used in batch experiment. So equation is different, but how we are seeing, that thing matter. Okay. So again I will put all the value, and I will be getting this final answer, that is 44.2 minutes. In the last question, now they have completely mixed flow reactor. Okay. It's completely flow, that is CSTR. They have completely mixed. Now they are asking if the hydraulic retention time is 50 minutes, the same initial condition, then what will be the effluent concentration, the concentration usually coming out. So this is very simple question. If you have idea about this mass balance and all this thing, you can just put your value and you can come out. But here, miss, I will just go in, miss, how to solve this CSTR equation. So again this is, so what will happen, that this is your CSTR. Again here what will happen, that A will be reacting to B, A will be reacting to B. So what will happen, that suppose, now imagine that concentration of A is given by Ct at any time C. So what will happen, the concentration at any time will be initial concentration of this A plus at what rate it has been decreasing, rate into time. At some rate, it will be decreasing at some rate now. So that rate into time will be concentration at that time. And this RC, we know that it is as a first order reaction, so it will be minus Kc naught. Okay. Because that will be depending upon the initial concentration. So I will be putting this value here, value of RC. Sorry, it will be, again there is one mistake. This will be uh, mm, uh, RC, not RC not. This will be RT. Okay. Huh. I will be putting that value, and after um, taking sorry, after bringing this term into this side, taking common ct, you will be getting this equation. So this equation is, miss, what happened, that there are many things going on this reaction, we cannot assume anything. So but what I have assumed, that this mass in mass out, everything is zero, settling is zero, only reaction is happening. And now know that only reaction is happening, so this thing will be followed, that A is reacting to B, this thing is happening. So I can derive this equation, and at any time t, the equation will be given as initial concentration divided by 1 plus kT. So for CSTR, we know this thing. You have initial concentration 21 minute, time is equal to 50 minute, k is equal to this. So at 50, after 50 minutes, your concentration will be 5.2 milligram per liter. So this was a very good question. You can expect this type of question in your examination. And you have to solve in this manner. So in for PFR you have either two option, either you can use direct formula or you can derive this thing. If you are not able to understand this derivation, no problem, please go through that book, you will be able to understand it. Okay, so this was the last question of the day. I have already discussed this thing, first order, second order, how to use that equation, and the final order of the reaction is first, depending based on this r square value. So thank you. So if you have any kind of question, so you can ask now. Yes, yes, Varun.
Sir, can you show the books again, please?
Of course, just 1 minute. The first book is this, surface water quality modeling by Steven C. Chapra. For this, the name itself suggests that is water quality modeling. This book is only for modeling thing. Okay, and the second, is it okay?
Okay, sir. Okay.
Book is this one. Second book is Chemistry for Environmental Engineering and Science by Swear McCarthy. You can take a screenshot of this thing. So I will suggest, if you are into environmental, do read. This is for experimental thing, and that book is for modeling thing. As a researcher, you should be aware of both thing, experimental thing also, modeling thing also. So you are in, currently you are in BTech, miss, what you are doing currently?
Sir, I'm doing a bachelor degree in waste management and water sanitation.
From which college?
Dayalbagh Educational Institute, Agra.
Agra. Okay, so you must have been doing this, in which year you are?
I'm in second year, sir. Actually, sir, water treatment is a part of my course. That's why I'm taking this course.
Oh, okay, so if you have any problem, I hope you was miss. I was able to make you understand everything. Yeah, there was
Yes,
any.
sir. Yes, sir. Sir, I have just one question. Can I ask?
Yeah, yeah, yeah.
So in third question, actually, Velanki sir told us a formula which is volume. Total volume is total volume of the sample into BOD of the sample is equal to the BOD of the seeded water or and volume plus volume of the sample which is taken in
Sorry,
this
sorry,
is
sorry.
like
I did not get you. Speak slowly.
Okay, sir. Okay, sir. Actually, Vilenki sir told us a formula which is Vm into VODM is equal to volume of seeded water into volume of BOD of seeded water plus volume of sample into volume BOD of sample. But this formula isn't working for this question.
No, that question. See, he has discussed three condition. He might have discussed three condition, that for performing experiment, you are talking about seeding. Seeding, na
Yes,
seeding.
sir.
So seeding is
Yes,
different
sir.
case. See, depending upon the data of the question, you have to interpret what kind of formula you have to apply. So here there is no kind of seeding. For a performing experiment, when we do seeding, generally it is said that when organic matter, presence of organic matter is very low in your system, we add kind of seed that is external organic matter, yeah, external microbes. So that will enhance my DO reading. Because suppose if you are performing some experiment and your initial DO is very zero, so your result final, obviously your final DO will be also very zero. So what we do that we I will do perform experiment in a such a way that my initial DO is very high. for
Okay.
that for that we do CO, for that we do seeding. So during that case, yes, the formula which is you are getting, that will be DO initial minus DO final. This term will be same. In what will happen, that in blank term you will be multiplying by the something called seed correction factor. Am I correct?
Okay, sir. Yes, sir.
So when you suppose see that generally you won't be facing that condition. So that is means that is a little bit sir has explained you a little bit advanced. So this is most commonly this term is used. But suppose if say, all these things, the type of experiment which we do for DO calculation depend upon the presence of organic matter. So what happens that suppose you will perform first of all you before doing DO we perform chemical oxygen demand. How much depending upon that chemical oxygen demand. Suppose chemical oxygen demand is very less, so we conclude that the presence of organic matter will be also very less. So obviously, and it is less. And now I am doing DO. So we have to add some external seed so that my reading is appreciable, so that I can apply this formula. Now suppose your initial value is 0.01 and your final value is 0.001. So there is no point of doing this experiment. So that's why we add seed. So in question there would have been some extra thing, like see this much of seeding is done. So they at this point there will be a seed correction term. Okay. And
Okay, sir.
seed is always done in for blank only. Just remember this thing. Okay.
Okay, sir. Yes, sir. I know. I understand where I was wrong. Okay, thank you, sir.
Okay. Thank you.